Okay, awesome. So, yep. Let me bring this back to the right screen. Sorry about the wrong screen. Starting out. But okay, tonight, for this stream, I'm gonna go over or video Palindrome, checking whether Palindrome is a singly linked list is a palindrome. Sorry, words. So first of all, what is a palindrome? Palindrome is a word, phrase, or sequence that reads the same backwards as forwards. For example, Madam or Nurses Run. Those are both palindromes. And also another one, again with sequence, that could be an integer, such as you have a sequence of 1, 2, 2, 1, or which would be reversed as 1, 2, 2, 1. Obviously, 1, 2, 2, 1 equals its reverse, so it's palindrome as well. Or something such as 1, 2, 3, 4 would not read the same as its reverse. Its reverse would be 4, 3, 2, 1, so that would not be a palindrome. So I'll bring this up to show you down the board. So again, palindrome, like I said, 1, 2, 2, 1. This is the forward and backward. 1, 2, 2, 1. Palindrome. But however, something such as 1, 2, 3, 4. Backwards would be 4, 3, 2, 1. Not palindrome. Also, as you can tell, these are equal. These are not equal. Sorry about the handwriting on that, but I'll fix that up real quick. Yeah, okay. Now let's see what a palindrome is. It's not a palindrome. Let me just see if I can bring this into the Zoom. Again, as you can tell, both of these are equal, so they're both palindromes. These are not equal. Forward and backwards are not equal, so it's not a palindrome. Okay, let's go back to our PowerPoint. Bring that back up to the page I want. Okay. Now, of course, 3 keys to solving algorithm data structure problems. Always want to remember, look at your choices. Also, in this case, we can either continue on or not. If it's not a palindrome, obviously no point in continue on. Constraints, obviously we're bounded by the length of the linked list. So the linked list has a beginning and an end. Can't go past that, so that's our constraint boundary. And our goal to return whether or not this linked list is a palindrome, true or false. And to do this, as I mentioned, we're going to be using a stack. Reason why a stack, I'll show you in the whiteboard. As I get that up there. The stack is a Leetcode data structure. Last in, first out, or you can also say it's a philo if you want to consider first in, last out. And think of it this way, last in, first out, it's basically the reverse of first in, first out. So, and a palindrome is a reverse of a string. So we want to get the reverse, you can use stack to get first order. Okay, now I'll show you the approach we're going to use in the code. Have it all commented out, and again later on I will also post this code in comments as actual code, not a image. Or handwritten. Okay, let's continue. So yeah, stack method. It's basically first we're going to traverse from list head to the tail and push every node into a stack, or node value into the stack. And to do this, we'll be using a temporary node, which is set equal to the value of node. So we're going to have to, reason why, we're going to have to traverse this list twice. We need 2 pointers to keep track. So yeah. So again, every node is loaded into the list. Every link node is loaded into a stack. And of course, with Python, you're going to append. However, you might find it confusing if you're coming from Java, C++ background, or when you use a stack, you just push. So I made note of that there. Basically, append is push in Python. Well, we're considering it. Also that stacks are basically just regular lists in Python, unlike other languages. Another good feature of it. Now we can have 2 choices. Here we go. After we load, everything is loaded into the stack. Sorry. A little late, a little tired. We'll traverse the list again. And for every visited node, we'll pop a node from the stack and compare the data of the pop node with the visited item in the linked list. If the value of the node in the linked list does not equal the value of the node popped from the stack, also we do not have a palindrome, and we can return false. However, if the value of the node in the linked list equals the value of the node popped from the stack, we can keep going in. I should not say return true. We can continue. Reason why I continue. Also, we currently still have a palindrome. A reason why we're not returning true. So if we continue along with this loop, there could be a case where, again, we come across a value in the linked list that does not equal the value in the stack. So, yeah. Okay, I'm going to get rid of this. And finally, sorry about that. Once we completely go through this, the linked list, and haven't returned false for any reason, because all the nodes in the linked list were equal to the corresponding values in the stack, can also return true. So yeah, because we also have a palindrome. So yeah, I'll finish that. Let me clean this up. I'll fix that up here. So yeah, again, like I said, if we finish going through the stack, or linked list, sorry. I have not found a mismatch. I'm walking all over the place. We'll be returning true, as we have a palindrome. Basically the reverse of the string equals for the string. Okay, and of course constraints, while linked list is not none, the current node we have is not null or none in Python. Make a note that if you're kind of, like I said, null in Java, or what other languages. other keyword of Python is that null is none in Python. Yeah, okay. So, this is the second part, like I said. We're iterating through the linked list second time. So stack value, like I said, will be popped from the stack. And if denoted value does not equal the stack value, also we have a mismatch, pound can return false. Palindrome will be false. And we can break from the loop. Second case, like I said, Palindrome will be, sorry, I have this set up. I have a surface down here which I'm using as my tablet. Camera's on this far side over here. It's surface is obviously tiny, and yeah, try to keep focused at the camera. Sorry about that. And also sorry about the background noise of my neighbor's broken air conditioning unit. It's going to be a long night. Okay. Let me just adjust this and tap it. Is this better? So yeah, else again, so we've continued through this loop, using all the nodes. Also keep Palindrome as true. And then iterate to next. We'll keep iterating to next until, of course, either we find a mismatch and return false, or we reach the end of the linked list. And finally, we'll return Palindrome, which will be true if this linked list is a palindrome, false if it's not. Okay. Now first, meantime, since we're going through the code, I'll continue on with this. Whenever you're doing a problem like this, always look for what I like to call low-hanging fruit. Basically, what if you give an invalid input? What do you do? How do you handle that? If you're doing an online problem, it'll usually say what to return. If you're doing an in-person interview, ask your interviewer this. What do they want you to return if you're given, for example, empty linked list? For this, I'm just going to return false. Empty linked list, so yeah. And of course, if you're familiar with linked lists, we have nodes, which they contain a value, the value can be either a string, integer, whatever, another object. Could even be a nested linked list. And then they also have a next, which points to next value in the linked list, or next node in linked list. This is for singly. Of course, doubly would be different, but as the problem is, singly linked list. Palindrome, if a singly linked list is palindrome, so this is what you have with that. Okay, so I have doing our check right there. We have our data structure, or object structure. Of course, our linked list class. Check if their input is valid. We're initializing Palindrome to true in this case because that's our default return. So once we finish going through all the values in the stack, sorry, what am I doing? Why am I doing that? Sorry about that. Let me also get rid of my face so I can see the screen better. So many screens at once. I'm getting used to this. Okay, awesome. Now I can see the full screen of the code. Okay, so yeah, also start initializing Palindrome true because that's our default case. We either find a break or area where the stack does not equal the linked list, return false, or we continue on until we reach the end of the linked list and return what we have for Palindrome, which will be true. Okay, and like I said, we're going to be doing loading the stack into the, or loading up the stack with the linked list. So that's what we're using temp node for as the first pointer, because we're going to need 2 pointers, one to go through the initial traversal load stack, other one to go through the traversal to see if it's a linked list, or palindrome, sorry. Sorry, my brain is ahead of my mouth tonight, but okay. So like I said, 2 traversals through this linked list. One to load the stack up, other one to check if the linked list is a palindrome. This one we're loading the stack up. And again, after that, we just check if it's a palindrome. So we're just using the regular linked list pointer. You know, we're popping every instance from the stack as we go. And if, like I said, if current node's value does not equal the stack's value, we don't have a palindrome, so we can return false. We can just break the loop right here. No point in continuing. And if like a else condition, else could be simplified, but I'm just have this written out for explanation purposes. We still have a palindrome, and we continue. So node we have. However, at this point we need to go to the next node in the linked list, check if it's we still have palindrome, so we need to increment node, or set node to its next. So node equals node.next. And finally, we just return whether or not we have a palindrome. Okay, let's go through the code, the worked out process. So first example I'll be going through is Madam. Obviously we're loading up right now. First step, load up the stack. So we node, and for this we'll be using temp node. So first instance, load M into the stack. Now we need to increment temp node to its next. And that brings us to A, so we need to load that into the stack. Now we need to increment temp node again until we choose next. We're at D now. D it. Increment temp node. What's next? Sorry about the handwriting. Now we are at A. A is into the stack. A is appended or pushed to the stack. Finally, we need to add increment temp node again. What's next? We append M to the stack. And obviously, if we try appending or incrementing temp node again, we'd hit null or none. So we can tell we've finally traversed the entire stack, the entire linked list. Sorry. Okay. Now we need to start the second part where we pop and compare. And I'll put temp node back there. Though we don't need it anymore, just to indicate that we've finally hit the end of the stack. Okay, end of the linked list. Sorry, I'm confusing you. Okay, so now node is at M. Stack, again, last in, first out. We'd be popping, so with that, we'd be popping M. Since that was the last in for a stack. Starting at the end of the stack, or you could also suppose use an array or regular list, just increment backwards, but conceptually it's easier to go with a stack. because it's obviously working from the end to the front as we pop. And of course, with the this traversal, we're going from beginning to the end as we traverse. Okay. Right now we're at M. First element, node's at the first element in the linked list. So we pop, and that equals the value we just popped. Let me keep a pop for consistency. Or I'll put that. Try to find a better good place to put this. 1 minute. I'll put pop out here. Pop would be M. So we pop to M. And does M equal the value in our linked list? Yes. So we continue. We still have it. So we pop, and I also put node.value. And let me just clean this up a bit for clarity reason. They're both equal. So continue on. We still have a linked list. Increment node now. We're now popping A. And node.value is A as well. They're both A equals A. Sorry about the crappy handwriting. So we continue on. We still have a linked list. Next, we're going to pop D. Increment node to D. Or increment node. And node.value right now is D. They both are equal, so we still have a linked list. Continue on. Now we need to pop A again. Increment node. Node.value is A. They're both equal. So we continue on again. Wait, this time we're going to pop M. As you can tell right now, stack is now empty. We're going to do an air handling trick. Make sure if the stack is empty, we're at the last node on the linked list. So now node is now M is what? Node.value is M. Also, we reached the end of the linked list. Stack is now empty. All the values have been equal to each other, so we can palindrome is true. Next example with the integers. Going to load the values into the stack. So to do that, we'll be iterating through linked list with the temp node. So see, first we're going to be loading 1 into the stack. also clean this. Node 1 node to stack, increment temp node to its next. Increment 2 into the stack. Or append or push 2 to the stack, sorry. Get my terminology right. 2 is in the stack. Now append increment temp node to its next. Or update temp node to its next. Append temp node's current value is now 2, so add that to the stack. Append it. Or push, depending on what language you're using. Finally, I'm going to do this again. Increment update temp node to its next. The current value of temp node is now 1, so we add that to our stack. Obviously with this, we don't need the last index because it's a smaller array. So we're going to ignore that. Now we have the, and also, like I said, we can't increment temp node anymore because if we do, we'd reach null or none. So we reach the end of the linked list. Now for the second part, check whether the values that are popped from the stack are equal to the values the current point or node in the stack, in the linked list. Again, like I said, make sure I said this clearly. We're going to make sure that the current value popped from the stack is equal to the current node in the linked list. Note that value in the linked list, so I don't confuse you. Okay, let me just get rid of this auto rotate thing. Okay, so we're gonna be working with node now, and I'll see it right now in the stack. We are at 1 step. So yeah. So note that value. So we're going to be popping 1. Note that value is currently 1. Sorry about the handwriting. Let me see if I can write this a little bit clearer. There's both equal. So continue on. I'll also pop that. And now we need to increment our node. Okay, it's a little long for this video. You can continue on with this. Now we're going to pop the next file in the stack. So we're going to be popping, that we pop will be 2. Sweet. We've also incremented temp node. Temp node is right now 2. Or sorry, note that value is 2. They're still equal. Continue on. And of course, as we pop, we need to remove because we're going to be popping the last element. So now we again popping 2 again. But now we need to increment node.val. Note that note that next is also 2. So yeah, both are equal still. Pop and max val are still 2. So we still have a linked list. Continue on. Finally, okay, node will be at this here. That's popped. And so anywhere else, pop is now 1. That's valid list. And okay, so yeah. And node.val is also 1. Both equal, so we have a linked list. However, Now node, if we increment again, node.next is none. So we've obviously reached the end of the linked list. And since we reached the end, nothing was, all the values matched, we just return true. Now I'm going to do another final case where we do not have a palindrome. And to do that, I'm just going to set to something like this. Dot value. Sorry, that looks terrible now. It's 3. I'll say 1, 3, 2, 1, and 1, 2, 3, 1 are not the same. So it's not palindrome. So let's clean that out. Obviously we've reached through that. So let's start this clean. Now, of course, we need to load up the stack. To do that, we'll put temp node back to the front. And also node to the front. It's a new problem. So sorry about the handwriting. So, temp node, or temp node is 1, so we append 1 to the list, or stack. Increment temp, or update temp node to its next. That is 3, so we append 3 to the list. Stack list. Continue on. We append 2. Continue going on. We append 1. Also, temp node can't go any further because its next value is none. So now we need to check if we have a palindrome. To do that, we'll start popping from the end. So, first thing we'll be popping is 1. Now our current max value, we have an incremented, or for temp node, for node now, is 1 as well. They're equal, so we continue on. We still think we have palindrome. Okay, now we pop 2 from the list to stack. We have incremented node. Node.value is 3. Ooh, these are not equal. So obviously we now know we do not have a palindrome. Can return false with it. Obviously, no need to continue because we already know one kit. It's not palindrome. Okay. Yeah. So again, let's go for the time complexity space. Also, we need to traverse the linked list 2 times actually. One to load the stack up, another one to check if the value pop from the stack is equal to current node index the linked list. So we can do 2 in, which of course big O notation will be O to the n, because linear. Time complexity expands linearly. Now space. Since we're looking at new data structure, that's of course the stack. The stack will be the same size as the linked list. We'd have to locate a structure of size n. Because of the stack. So space will be n, big over n. And that's also linear. As the size of linked list grows, the size of this stack will grow. Think of it that way. Okay, so I think recording went better than the last one. Still a few areas of improvement are needed, but hey, again, practice makes perfect. And again, like I said, later on I'll cover the recursive approach, followed by probably another stream of Intro to Golang, then an Intro to Helm, or Intro to Helm, then an Intro to Golang. Mix it up a bit. Okay, again, good luck. Take care.